So you know the drill by now. We are going to just add more complications. We're going to go from zonally symmetric case to zonally varying basic state. The Riehl and Malkus that we talked about in the context of convection, that Riehl also had observed already that the intermittent appearance of high tropospheric westerlies on the equator is a foreign thought in classical views of general circulation, yet there is evidence that they do occur. Since flow in high levels is so unsteady, coupling at high latitudes between the high altitudes between the circulation of the northern and southern hemispheres promises to provide an important link in understanding of the fluctuations of the general circulation. Okay, and he also noted that an intrusion of extratropical type disturbances into the heart of the tropics in the region of tropical westerlies. We have already kind of implied that the westerly duct is where the equatorial trapping was weakened and the equatorial waves stretched to higher latitudes, and the trapping was affected by this as well. So this is now looking at the other way and looking for extratropical signatures coming in. Reminding ourselves of the basic state, we have the mid-latitude westerlies, we had the easterlies with the westerly duct in the middle, both in the Atlantic and the Pacific, that we wanted to look at again now in the context of signatures or perturbations coming into the tropics. Okay, we can also look at the longitudinal variability of the deep tropics in terms of zonal wind component. These are just different seasons, June, July, August, SON, DJF, MAM. Same thing here, but looking at zonal and meridional wind components in the longitudinal directions averaged over 5 north, 5 south, which is the deep tropics. So you can see we had again the let's see here, this is zonal wind component, so this is positive, so westerlies and easterlies. Okay, let's of course we'll later on come back to reminding ourselves of the vertical shear as well, because one of the ways the perturbation can go up in the deep tropics, as we saw, was in the case of vertical shear, you have vertical trapping and energy propagation issues as well. If you just take the flow field from the real world and time variability, you can look at deviations around the long-term averages, let's say here for January and February. So you can then compute perturbation kinetic energy. So looking at the mean basic state of easterlies here and the westerly duct, if you look at the potential perturbation kinetic energy in meters squared per second squared, which is defined as u star squared plus v star squared divided by 2, where these are basically deviations from the long-term mean in a time band of 6 to 60 days or so. Usually you pick a time window in which you look for the deviations. And you can see that for both January and February, the perturbation kinetic energy is high in the mid-latitudes where you have lots of energetic activities. This is in the upper level at 200 hectopascal. And in the deep tropics, the easterlies block the intrusion, whereas in the westerly duct you have intrusion of the perturbation kinetic energy or increase in the upper level perturbation kinetic energy in the deep tropics. Okay, so this tells us that the ideas of Riehl from the 1950s and Charney from the 1960s begin to be real and true. And interestingly, they did this during the time when there was not much upper level data, so they were just thinking from physics about these ideas, which is remarkable. If you look at the correlation between the basic state and the perturbation kinetic energy in the deep tropics, so let's say you are just averaging here between 5 south and 5 north, and you are going along and producing a scatter plots for each season in terms of the relation between the basic state and the perturbation kinetic energy. take the two time series and correlate them, you'll see that for the winter, boreal winter months, spring, summer, and fall months, as the basic state becomes more and more easterly, the perturbation kinetic energy drops off, which is consistent with what we saw here for just 2 months. This is with a much longer time series going from 1972 to 1982. And the correlations are quite significant, remarkably high, 0.84, 0.83, 0.72, 0.77, way above the 5% and 1% confidence levels. If you know statistics, you know what that means, but otherwise just take it that the basic state greatly affects the perturbation kinetic energy, which indicates the intrusion of the extratropical perturbations into the deep tropics, okay, in all seasons. It's obviously maximum in the winter, when the winter hemisphere tends to have maximum equator to pole temperature gradient. The storm tracks tend to be strong, and you get very strong mesoscale activities, eddy activities, storms, and so on and so forth. So these high correlations basically raise some interesting questions, where the potential kinetic energy maxima the result of in situ development of disturbances in the tropics from the lower levels, let's say injecting energy into the higher upper levels. If this were the case, then one would need a mechanism to allow deep vertical penetration of tropical modes into the upper troposphere. This hypothesis seemed unlikely given the scaling constraints introduced by Chani, where we remember he said if the scales of the tropical circulation is 10 to the 6 meters, then the system tends to be barotropic and there is no real coupling between the lower level and the upper level. However, we saw before that the impact of vertical shear on vertical propagation of equatorially trapped modes is very clear. Positive vertical shear, westerlies above easterlies, would be conducive to a greater vertical group speed, which means energy propagation, than if the shear were negative. Thus, it would seem that it is possible for equatorial modes to influence the tropical upper troposphere, creating regions of high pKe in equatorial westerlies. Okay. Could the low latitude potential kinetic energy maxima be produced by propagating modes from the higher latitudes through specific regions of the tropics? That is, could the longitudinal variability of the basic state, which we just saw, allow preferential penetration of extratropical modes toward the equator? So now the physics we looked at before hopefully makes more sense after we looked at this potential kinetic energy. So we'll do some numerical experiments in a zonally varying basic state to see these things. So prescribed basic states are basically zonally symmetric easterlies in the deep tropics with weak westerlies off in the extratropics. Or you have a weak westerly duct, so you have a more realistic zonal asymmetry with the easterlies on either side with westerlies in the middle, as we saw before. Or you can make it more realistic with still the easterlies but much stronger westerlies here with strong meridional shear. Okay, so how do the forcing in the extratropics then propagate into the tropics in this case? How do they project onto the equatorial waves that we have been discussing? Okay, so we will do that in the next podcast. So slowly we're moving towards realistic physics to say one of the ways tropical baroclinic processes in terms of convection weakening the stratification may be triggered from the extratropical perturbations coming in. So we will see where are the favored locations where they can come in.